Hi, welcome back to another lesson. In today's lesson, we'll be looking at how to find the eigenvalue of a matrix. We'll be using a 2x2 matrix for a start, and in our next lesson, we'll be using the 3x3 lesson, and later on, we'll also see how to find the eigenvalues and eigenvectors. Now, to ensure you get these lessons, please do hit the subscribe button. That way, you'll be sure you get notification anytime we create our lessons. That said, let's get into class. In many engineering or technology solutions like vibrations, oscillations, you come across this equation where AX is equals to lambda X. Now my A here is actually a square matrix. It's a square matrix. My lambda is also a scalar, is not a matrix. Lambda in this case is not a matrix, it's just a scalar. Now, but also usually it always occurs such that x here will be equals to 0. Now let's see this. This is AX is equals to lambda x. You agree with me that AX minus lambda x will be equals to 0. Such that A minus lambda into x should be equals to 0. But when you look at A and you look at lambda, A is a matrix and lambda is a scalar. Now we cannot subtract scalars from lambda, scalars from matrices, neither can we subtract matrices from scalars. So we introduce what is called an identity matrix. I here is what we call an identity matrix. That's an identity matrix. Now so that A now minus lambda I. Now, the determinant of A minus lambda I into x is equal to 0. Obviously, the determinant of A minus lambda I will be equals to 0. This is called a characteristic equation. This is what we call a characteristics equation. Now let's take an example so that we'll start with the 2x2 matrix like I promised. Then in a subsequent lesson, we'll see the 3x3 matrix. 4, 2, I have this matrix A minus 1 and 1. Now that means to find the eigenvalue of this, that means we'll be looking for lambda. I'll be saying that A now minus lambda I determinant is equals to 0. That is this matrix A, that's 4, 2, minus 1, and here is 1, minus, I have the identity matrix 1, 0, 0, and 1. Your identity matrix is such that all the diagonals are 1. Now multiplied by lambda will be equals to 0. So that this becomes 4 into 2 minus 1. Here I have 1 minus, I'll now open this bracket. 1 times lambda, this becomes lambda, 0, 0, and 1 again times lambda, this becomes lambda. Now my overall matrix will imply I'll now have 4 minus lambda, that becomes 4 minus lambda, minus 1 minus 0, that's minus 1, 2 minus 0, that's 2, then 1 again minus lambda, that's 1 minus lambda is equals to 0. Now I've actually written the equation. Now my characteristic equation is actually the determinant of this 4 minus lambda into 2 minus 1, 1 minus lambda is the determinant is equals to 0. Now let's take the determinant of this expression. In case you missed our lesson where we treated determinant of a 2x2 matrix, please do not hesitate to check this link it should take you to the determinant of a 2 by 2 matrix. Now, to find the determinant of this matrix, we'll be picking the major diagonals, that is 4 minus lambda times 1 minus lambda. That will be 4 minus lambda into 1 minus lambda minus, here is 2 into minus 1 is equals to 0. So that let's open this bracket. So that 4 times 1, that's 4, minus 4 lambda minus lambda plus lambda squared. Now I have minus here, I have 2 and minus 1. That automatically becomes plus 2. 2 times 1 is 2, is equals to 0. Now let's rearrange our equation. Rearranging the equation, this becomes lambda squared minus 4 lambda minus lambda, that's minus 5 lambda plus 6 is equals to 0. Now, so that my lambda squared minus 5 plus 6, this is a quadratic equation. We can use any of the methods to solve this equation. We can factorize. Let's factorize. So that when I'm factorizing, it becomes, I'll pick lambda squared and I'll pick 6. That will be 6 lambda squared. I'll also leave a link in the description for our lesson on how to factorize a quadratic equation, so that in case you have gray areas with factorization, you can just look at it to help you through. Now, what are the factors of 6 lambda squared that will equal to minus 5 lambda? That's minus 2 lambda and minus 3. So that this is lambda squared minus 2 lambda minus 3 lambda plus 6 equals 0. Obviously, lambda will come into lambda minus 2, this lambda, minus 3, bracket open, it becomes lambda again, minus 2 equals 0. Obviously, we have that lambda minus 3 is equals to 0. So that this implies that lambda will be equals to 3. Again, we also have that lambda minus 2 is equals to 0. This implies that lambda will be equals to 2. So that our eigenvalues are, my eigenvalues are 3 and 2 for this 2 by 2 matrix. Now with this, I hope you understand how to find the eigenvalues of a 2 by 2 square matrix. In case you have gray areas, please do not hesitate to reach out to us through the comment section and we'll be there to respond to you. Thank you for staying with us, and do not forget to give us a thumbs up by hitting the subscribe button. See you in our next class.